expert.
Thank you.
Go ahead.
I just flew in from Orlando. There was another big conference. So let me get started off. It's Friday afternoon. And hopefully we could keep this entertaining and informative and share some knowledge that we've gained in the cybersecurity space. Again, thank you to the Global Big Data Conference and Dr. Murthy, you and Lena for the invite and for the audience and the rest of the speakers. Pretty stellar lineup as always. So just as a background, digital health startup investments in 2021 was $24 billion. That was 3 times more than that of cybersecurity. Both of these things combined, I mean, they're getting a lot of attention. The US cyber insurance spending for all industries in 2021 was $15 billion. There was a very interesting Merck legal case. I'm not going to mention that here. But the bottom line was cyber security attacks are not an act of God. So there is some very interesting insurance developments just in the last few months. The number of data breaches in healthcare were the worst in 2021, something in the order of 50 million unique breaches. The worst thing I remember was in 2015, which was actually 120 million, only because the Office of Personnel Management of the US government got hacked. That was more than 70 million. So anyway, totally, you know, we are facing an unprecedented attack from our digital networks, analog networks, hardware and software. The 60-40 ratio of internal to external cyber attacks flipped in 2020. They were mostly external state level actors. Ransomware quadrupled in healthcare in 2021 compared to 2019. The current events in Ukraine, the Ukraine war is being fought on 2 fronts, the physical front and the cyber front. Yes, the cyber front is probably not as tactical and you don't see some of the actions going on, but there is an active event on the cyber side going on as well. So this is kind of the dark world of cybersecurity we live in, especially in healthcare and the life sciences. And what I'll try and do is give you kind of a brief introduction of what we're thinking about the data, you know, how we're looking at this from a platform perspective. I just came from the HIMSS conference, the Health Information Management Systems Society conference. The top of mind for most of the CXOs in both healthcare and life sciences are getting kind of merged nowadays into this mashup that I never thought would happen in my lifetime. There's a big fence jumping going on both sides, and they're all data-centric issues. Most organizations are in healthcare are in year 0 or year 1 of a 5-year cloud roadmap. The definition of cloud that a very highly regarded CIO in healthcare, whose name I shall not mention, was that the cloud is your shit managed by somebody else. And you need to understand what your shit is first. This was not my words, this was his words. And so you can't really forklift the 400 or up to 1,000 legacy applications that are in an average hospital about 500 to 1,000 beds, which is very difficult to do because there's so much legacy information, legacy informatics, legacy application layers, and so on. Not just from a data perspective, but also from a cybersecurity perspective. So what that leads you is this other big issue that people are now trying to understand, which is SBOM, or software bill of materials. And this actually not only combines the 1,000 independent software vendors that run applications, but also consumables and hardware and IoT and devices that run the healthcare systems and the life sciences organizations' daily operations, which make it more complicated, more intricate, more complex. The implementation layer for SBOM, or software bill of materials, is two. I'll give you an example of 2. One is SPDX. It is more an ecosystem perspective. The other one is SWID, or software ID. What this means is you're kind of building version control at massive scale across software and hardware. Now, this does not only just deal with data, but also metadata. And you're not only sharing taxonomies, but also ontologies and very complex application building techniques across the enterprise and across the ecosystem in healthcare, which makes it pretty complex to handle from a data perspective and a data science perspective. All that having said, I would say, having been in this field for a little while, it's not about software, open source software, or cloud, or multi-cloud, or networks, or federated networks, or it is about data. It's data, data, data. It's all about data. Now, in the last 2 years, we've seen telehealth, public health, preventive medicine, and what the pandemic taught us is it is about the informatics. It's about the data. And therefore, protecting that data becomes a lot more complex in these areas. And I do have to mention IoT and devices again, because these ecosystems are now smack dab in the middle in fog networks on the edge, in the middle of all of this data. And I also have to do a very quick mention of this thing called FAIR data, which started in the pharma industry. It stands for findable, accessible, interoperable, and reusable. And now these are pretty big concepts. They're not new concepts. But just in the pharma industry, fairable data is something like a $20 billion market. So, if I take all of this and then kind of look at risk, how do I put this? This actually came from a song from Frank Zappa many years ago. It came from an album called Joe's Garage Act III. But the core concept of Frank Zappa's songs actually came from Lord Kelvin, the inventor of the Kelvin temperature scale. And his basic tenet was, if you can't measure it, you can't understand it. And from our perspective, as we've looked at cybersecurity data, I put a few more kind of nouns here. If you can't name it, you can't find it. If you can't find it, you can't observe it. You can't observe it, you can't measure it. If you can't measure it, you can't understand it. If you can't understand it, you can't report it. And if you can't report it, you don't know what the purpose for the business function you're doing is. And instead of reading all this, fair risk models and other things that go into here, I will kind of tell you the questions that the chief security officers, the governance and risk boards are asking me. And, when you try to put this together in the context of a risk model, the first, my top 10 questions are this, how is the data distributed? How is it stored? How is it computed? Where is the metadata? That's the first question. The second question is, when and where is the organization expecting fraud and abuse? In other words, where are the weaknesses for attack, for vulnerability, if I can say it right, it's Friday afternoon. What are the process for vulnerabilities to understand where the process happens at the endpoint level? The endpoint here is not the clinical endpoint, but machines that run your systems on the edge and inside your enterprise and so on. The third issue is, what are the trajectory of breaches? What are people looking at in your system? What are the encroachments? What does it look like from your past information? When and where did the largest breach occur? In the last 5 years, in the last 10 years? Are there any legal proceedings underway? What are the reporting agencies that you have to actually report all this data to? Number 6, what is the vector for past data breaches? Can you draw me a time series histogram of internal attacks versus external, negligence from your employees, system errors, bugs, external state level attacks, ransomware, et cetera, et cetera? Number 7, what is the trajectory of costs of each of these breaches? And what are the largest cost issues for your organization for cybersecurity? Number 8, has automation helped? Actually, EMR systems has not really helped automation. It has actually hindered in some instances, because the physician is never looking at the patient anymore. Their heads down looking at their screen. So interaction and observable data becomes very hard then. So how are you going to solve all these issues in a cybersecurity context? What is the maturity level of the organization for enterprise risk? Is there one? Is there even a scoring for maturity for your organization? And finally, is there a cumulative organization-wide CXO level and board level risk and governance approach in place? My last slide before I actually turn it over to my, again, the real data scientist in the room here. I actually did a summary of our entire, functional ecosystem within what we do from an endpoint platform perspective. And I could tell you, having done this for 20 plus years, I used to be an FDA inspector, a consulting inspector, trying to figure out how organizations do FDA level, compliance. 20 years of doing this. My first year of doing this was a very famous year zero bug. It was actually called the Y2K bug then. And I've actually, the mnemonic, the acronym is stuck in my head. Yeah, it's IPDRR. I will repeat it again, IPDRR. This has not changed in 20 years. IPDRR stands for identify, protect, detect, respond, and recover. And these are big umbrella quality systems issues like NIST 800, 8374. I'm kind of rattling this off because I've been doing this for a while. ISO 27005 for the cloud, FDA 21 CFR parts 1152 and 820. All of these are quality system issues again. But at the core of all this is 7 basic functions. And again, the top one is risk. If you need to understand cybersecurity, you need to understand risk, which includes functional risk, legal risk, business risk. And then the next part is data. And data is becoming this big thing nowadays. And from a cybersecurity perspective, what is the privacy context of all of this data? What is the trust context of all of this data? And the other 5 are application layer. Cybersecurity as a kind of an umbrella issue, which has multiple sub issues. I won't talk about these in detail today. What is your contingency model? What happens when things go wrong? What metrics are you measuring for an organization? What kind of training are you giving your employees and your executives in cybersecurity? And let me end with biology. I kind of wandered to biology after engineering. And the original linear chain in biology was what I'm sure Naveen knows well. It was called the von Neumann machine. It's basically a tape with a fixed set of information. And the first von Neumann machine on planet Earth was messenger RNA. We all kind of know mRNA now because most of us have gotten vaccines in our arms, and that's kind of mRNA based. So messenger RNA takes information inside the nucleus and moves it into the protein factories in the cytoplasm at a massive scale. Right now, everybody in this audience is actually creating something in the order of 100 trillion molecules of hemoglobin every second. And the question then becomes, how can we build systems at that scale and the basic information engine is a linear chain. So let me get off my soapbox. I'll actually tee up Naveen. Naveen will start talking about, what our context with linear chains are. Naveen, take it away.
Thank you, Sanjay, for that immunology example.
You're going to stay, Sanjay? You're going to stay there till the end of the presentation?
Yeah.
We'll be here for questions if there are any. Thanks.
Good enough. Good enough. Okay. Go ahead.
Yeah. Thank you again. So I'll be talking a little bit about data science and at Tanium. And so what exactly what is Tanium? If you ask someone on the street, what is Tanium? Tanium is software, and the software is both server software and client software. And the Tanium server establishes communication in enterprise networks with it could be up to from anywhere between small networks like 5,000 endpoints, which are laptops or endpoint devices on the network, all the way up to 10,000 or 100,000 or even 1 million endpoints if you consider government customers. Now, what the Global AI Conference today was a lot about modeling, AI models, and so forth. What we try to get here is not only talking about modeling, like risk modeling, as Sanjay mentioned, the fair risk model, but also how do you collect data at scale using this particular Tanium platform on the left. And after modeling based on the data collection, how do you remediate cybersecurity as well as operations use cases. So Tanium not only collects data at scale, but also remediates risks in cybersecurity and operations. So let's just go over here the data collection as the platform. This is on the left here. So we have a Tanium server, and as well as endpoints. And the advantage of the Tanium data collection platform is that first of all, it's fault tolerant. It's self-organizing in a decentralized way. It's scalable up to, like I mentioned, up to even 1 million endpoints using linear orbits of communication. And also it's very fast. It's speed at scale, and the speed by which we can ask questions from the server to the endpoint devices is within 15 seconds for most questions asked, as we will go through. And even for complex data collection questions, we can get data back within 60 seconds even, if we also utilize edge computing on each of the client devices. Now, like as I mentioned, not only can we collect data, but we can also control and mutate the state of endpoints by launching executable programs on endpoints. We can reboot endpoints, we can quarantine endpoints if there's a risk, cybersecurity risk, and we can, in general, deploy actions on endpoints that mutate the state of endpoints. So, but just before, maybe this is a little bit to qualify sort of why the architecture is in the particular linear chain form. What happens is when we install Tanium software, which is a server and client, as an endpoint comes into the network, it first registers with the server, and in a decentralized way, it asks from the server, first of all, what are its neighbors? And from a peer-to-peer networking standpoint, you might think about BitTorrent or other types of peer-to-peer systems that have been well known since the 1990s. And beyond that, the main difference here is a linear chain. So the communication is very fast in local area network peer connections, which are continuous, long-lived connections where you're able to exchange files and other data that for questions. Once endpoints register with the server sort of gives them nearby peers, and the peering process establishes a backward leader. Leader here, the server communicates with only that leader in the backward chain, in the backward part of the chain, and then each endpoint establishes communication one by one, forming the linear chain, all the way to the forward leader, which aggregates data back to the Tanium server. So I can ask various questions, and client software, Tanium software, executes sensors which extract data from the endpoints, and that data is aggregated back to the server. So this is our data collection format. And so a sensor is a script that's executed synchronously across all these endpoints, and then the server asks, okay, collect the data from the results of that sensor. A sensor could be asking a computer name. What kind of operating system is it? Is it Windows, Linux, or some other operating system, Mac? And the installed applications, running processes, free disk space, whether the RAM is on there, whether files exist on that endpoint, and so forth. Again, compared to the right-hand side here, we have a tree topology. The tree topology is you need secondary servers after the main server. And this is more utilizing the wide area network. And so the wide area network is often congested and is not as fast as the local area network for a lot of the communication. I mean, the Tanium server, the Tanium architecture is very, very quick at collecting data once you ask a question and execute sensors. Now, the other part beyond the data collection, like I mentioned, is actions. And actions are you execute, you deliver packages to all the endpoints, and they are able to deliver run executable instructions to, for example, they can install software, reboot the machine, as I mentioned, and you may also run actions periodically to have a policy that for patching computers, for cybersecurity patching, or enforcing other policies that maintain safety of the entire network. Again, this is at scale. So this Tanium has customers on the government level, big banks, as you can look at our website. And so this is a full-fledged commercial enterprise software. So now if you go to the second, next slide, Sanjay. Now beyond, okay, if you look at sort of AI modeling, once you collect data, I mean, there's many different ways of collecting data. So you're able to collect a bunch of data and then you run your modeling after that. Another type of standard way to extract data that people are more perhaps familiar with is a streaming communication system. You might have IoT devices, you might have other type of ad hoc networks where each endpoint might have some driver, or so there's some hardware involved, and then you have an event recorder, maybe mobile devices, and you have an event stream, and you stream events to a cloud receiver. And in the cloud receiver, you might have a Kafka system that takes all the messages coming from all the endpoints and then does AI modeling in the cloud. Again, this is just for data collection, not talking about sort of the remediation part where you might broadcast some sort of decision on all the endpoints as well. But so just to compare and contrast, these are two different architectures. Tanium also has cloud streaming directly from the endpoints. One benefit of a data collection system such as Tanium is that you're able to aggregate along the linear chain and scale quickly and get answers back in aggregate. And so you can execute, for example, SQL queries that are more like MapReduce type of queries that operate quicker, and you don't need to collect all the data if you just want sort of the insight that you're trying to get. The Tanium server can also be in the cloud, in the Tanium cloud, and that part is similar between the cloud receiver and the Tanium server. So, but the endpoints are out there in some particular network configuration. So, okay, next slide, please. Now, what kinds of data statistics, and this is just a very small sampling of what kind of data that we can obtain from this data collection platform. So, for example, for cybersecurity, there's something called common vulnerabilities and exposures that the government and other cybersecurity experts publish daily. Very common ones. Recently, the Log4j was a vulnerability in the Apache Log4j library, which allowed attackers to gain a foothold in many different enterprises. So here we can, what I plotted was just on the x-axis are the computers in a test network, and on the y-axis is the number of vulnerabilities per computer. So we can see that there are some computers that have a lot of CVEs that you need to address and patch, and other computers, maybe they're not used as much, or aren't being used in the test network as much. They don't have it, or they're up to date in patching. They're fine. They have less CVE vulnerabilities. We also have other unique threat alert types. There's intel coming from many different sources and funnels. And we can, again, here, this is another test network, same test network, but different types of data coming back, the number of unique threat alert types. Again, these are just count data, but we can also get specifics about what kinds of alerts, and then direct connect into computers to see further fine-grained information. We can also get, as I mentioned, installed applications, the applicable patches to apply, the open ports, for example, and running processes, in addition to a lot more risk data. Okay, next slide, please. So the purpose of this data collection platform, as data becomes more and more valuable, is okay, how do we, after we collect this data, what we want to make decisions, right? And this has been a theme throughout this global AI conference, is that, okay, we have explainable AI, we get data, we make models, but at the end of the day, we want to make decisions that, in our particular case at Tanium, the decisions we make are on behalf of our customers who take those decisions to lower their risk in cybersecurity, to in the case of operations, to fix computers or to take computers offline if they're suffering from performance issues and replace them with newer machines, to make sure that certain servers that are critical to the infrastructure of their enterprise are up to date and with the most recent software, et cetera, right? So this is all enterprise management. So once we get the data from this data collection platform, we then can do various things. For example, risk modeling. We get back a bunch of metrics. And in terms of explainable AI, well, we can have human-based rules that are, or tree-based systems. These have already been talked about in this Global AI conference. And then the key here is this closing the feedback loop. Once we, for example, measure the amount of risk, which could be just a linear scoring based on the criticality of machines, the number of risk vectors coming back, and also inversely proportional to the number of compensating controls. For example, if you have anti-malware, if you have other programs running on each endpoint that block cybersecurity attacks, then you have a better risk score. But based on your risk score, we then want to remediate. And so one of the things is each CVE has a recommended patch. And as we patch the system, the entire enterprise, we can see the risk score being lowered. And this then becomes a more and more automatic, intelligent AI system for cybersecurity and operations management. And that is what we are working towards at Tanium. And as we automate this more and more, hopefully with AI classifiers, like some of which have been discussed in this conference, this system becomes more and more intelligent and requires less and less of human operators and more artificially intelligent algorithms to reduce the risk score. Okay, and then the final slide. This is one of our papers from our paper presented about 5 months ago or something at the proceeding of the very large databases. If you combine the linear chain, this data collection environment, with also edge computing, we can also do, we can collect data, but we can also do a lot of compute on the endpoints. We can't take too much compute. It's a federated system. It's not a distributed system. It's a federated system because each endpoint is its own entity, and we're not allowed to execute, more CPU than we're allowed. Like for example, 5% cap on CPU, and same thing with memory. But we can, for example, run file processing or other background tasks. In this particular case, we run compliance checks for GDPR, which is data protection, personally identifiable information, passwords found on endpoints. And then again, you can search for log4j just by typing in our federated search engine whether log4j exists on any file. Now, this edge compute and cloud architecture is enabled by the fast linear chain, which allows us to search for any phrase that might occur across the enterprise and into the data which sits at the endpoint. So we don't need to collect all the data. And edge computing leaves a lot of the data on the endpoint, but we only take the salient data or the computed transformed data off the endpoint and then exhibit that centrally. And so this becomes very powerful because we get the compute from all 100,000 machines. We don't have to centralize the data, especially for certain sensitive data. We're not allowed. Cybersecurity data is not like social data. We're not allowed to collect everything off the endpoint, especially if the endpoints are important or critical to a particular enterprise. So yeah, and then that's it. I mean, just the last slide. This is by General George Patton, who's an Army general in World War II. So take calculated risks. This is quite different from being rash. So he was successful. He lived through both World War I and World War II, and in particular the commanding armies in World War II after the Normandy, the Normandy invasion. So that's what we want to try to do at Tanium. Try to calculate the risk and reduce risk, and do it in a data-driven way, as well as in a performant way, so that we don't centralize all the data. Thank you.